When working with or around energized electrical conductors, safety should always be the foremost concern. There are several codes, standards, and guidelines to help ensure the safety of personnel. NFPA 70E, the standard for electrical safety in the workplace, provides comprehensive guidance on electrical safety requirements for employees. Section 490.24 of NFPA 70E generally requires to energize an electrical conductors before working on them. This is the safest approach and should always be the first consideration. However, if the energizing is not feasible, Section 490.41 states that energized conductors must be guarded to prevent accidental contact. This means implementing measures to physically protect workers from coming into contact with live parts. OSHA Regulation 29 CFR 1910.333 B1 requires employers to ensure that electrical equipment is free from hazardous conditions that could cause injury or property damage. This regulation underscores the employer's responsibility to provide a safe working environment. IEE Standard 1584-2018, particularly Section 4.61, recommends that energized conductors should be enclosed or guarded whenever possible. Annex J-1 of this standard provides further guidance on working on energized conductors, focusing on risk assessment and mitigation techniques. In a situation involving multiple 11 kV feeders haphazardly arranged in a trench, specific precautions are crucial. Firstly, a thorough hazard assessment of the trench and cable layout must be conducted. This assessment should identify all potential hazards, including but not limited to exposed conductors, damaged insulation, and the proximity of energized cables to each other. Secondly, the work area must be cleared of any debris or obstacles that could impede movement or create tripping hazards. A clear work area reduces the risk of accidental contact with energized components. Thirdly, all exposed conductors should be covered with appropriate electrical insulation to prevent accidental contact. This might involve using insulating blankets, wraps, or other protective materials. Fourthly, physical barriers should be erected around the energized conductors to prevent accidental contact from tools or materials. These barriers can be constructed from insulating materials and should be designed to withstand the voltage levels present. Fifthly, all personnel involved in the work must wear appropriate personal protective equipment, including arc-rated clothing, gloves, and face shields. The PPE should be selected based on the potential arc flash hazard, as determined by a qualified electrical safety professional. Sixthly, access to the work area should be restricted to essential personnel only. This minimizes the number of people exposed to the hazards. Seventhly, clear communication protocols should be established to ensure that all personnel are aware of the energized status of the conductors and the potential hazards involved. This can include regular briefings, signage, and the use of hand signals. Eighthly, close coordination with other teams is essential to ensure that no work is performed that could endanger the safety of personnel working in the trench. This requires careful planning and communication to avoid conflicts. In addition to these specific precautions, there are several other recommendations to consider. 1. Consider using a cable puller to minimize the need for personnel to manually drag the cables through the trench. This reduces the physical strain on workers and minimizes the risk of accidental contact with energized cables. 2. Have a plan in place to de-energize the conductors or evacuate personnel in the event of an emergency. This plan should be clearly communicated to all personnel and regularly rehearsed. 3. Document all procedures and precautions taken in writing to demonstrate compliance with safety standards. This documentation should include the hazard assessment, the measures taken to mitigate the risks, and the PPE used by personnel. It is always recommended to de-energize electrical conductors before working on them. However, in the absence of a viable alternative, the precautions outlined above can help mitigate the risks as much as possible. Remember, electrical safety is paramount, and any work near energized conductors should be approached with the utmost caution and respect for the hazards involved. Working with high-voltage electricity presents significant hazards that must be understood and mitigated through proper planning, training, and the use of appropriate safety measures. The electrical hazards can cause severe injuries, including electric shock, burns, arc flash, and even death. Therefore, it is crucial to prioritize safety at all times and to follow established safety protocols. The hierarchy of controls is a systematic approach to hazard control that prioritizes the most effective measures for reducing or eliminating risks. This hierarchy consists of the following levels, in order of effectiveness. Firstly, elimination involves removing the hazard completely. In the context of electrical work, this means energizing the electrical conductors before starting any work. This is the most effective way to eliminate the risk of electric shock and arc flash. Secondly, substitution involves replacing a hazardous substance or process with a less hazardous one. In some cases, it may be possible to substitute a high voltage system with a lower voltage system, thereby reducing the potential for electrical hazards. Thirdly, engineering controls involve implementing physical changes to the workplace or equipment to reduce the risk of exposure to hazards. Examples of engineering controls include installing barriers to prevent accidental contact with energized conductors, using ground fault circuit interrupters to protect against electric shock, and providing adequate ventilation to remove flammable vapors. Fourthly, administrative controls involve implementing procedures, policies, and training programs to reduce the risk of exposure to hazards. Examples of administrative controls include lockout/tagout procedures, safe work permits, and regular safety meetings. Fifthly, personal protective equipment involves providing workers with equipment to protect them from hazards. Examples of PPE include arc-rated clothing, gloves, face shields, and safety glasses. PPE should be used as a last line of defense after all other control measures have been implemented. Before commencing any work near energized electrical conductors, a thorough hazard assessment must be conducted to identify all potential hazards. This assessment should consider factors such as the voltage level, the proximity of energized conductors, the presence of flammable materials, and the environmental conditions. The results of the hazard assessment should be used to develop a detailed work plan that outlines the steps to be taken to mitigate the risks. Lockout/tagout procedures are essential for preventing accidental energization of electrical equipment during maintenance or repair work. These procedures involve isolating the equipment from all sources of energy and then applying locks and tags to the energy isolating devices to prevent them from being re-energized. Only authorized personnel should be allowed to perform lockout/tagout procedures, and they should be properly trained in the procedures. Safe work permits are written authorizations that are required before commencing certain types of hazardous work, such as work near energized electrical conductors. The permit should identify the hazards involved, the precautions to be taken, and the personnel authorized to perform the work. The permit should be reviewed and signed by all personnel involved in the work. Regular safety meetings should be conducted to discuss electrical safety issues and to reinforce safe work practices. These meetings should provide an opportunity for workers to ask questions and to share their experiences. Safety meetings should be documented to demonstrate that they have been conducted. Workers who work near energized electrical conductors should receive comprehensive training on electrical safety principles, safe work practices, and the use of PPE. The training should be tailored to the specific hazards and tasks that the workers will be exposed to. The training should be conducted by qualified instructors and should be regularly updated. Workers should be evaluated to ensure that they understand the training material. Arc flash is a dangerous phenomenon that can occur when a short circuit creates a high-energy electrical explosion. Arc flash can cause severe burns, blindness, and even death. To protect against arc flash hazards, workers should wear arc-rated clothing and face shields. The arc rating of the clothing and face shield should be appropriate for the potential arc flash hazard. Grounding is an essential safety measure that helps to prevent electric shock. Grounding provides a low-resistance path for fault current to flow back to the source, which causes the circuit breaker or fuse to trip and de-energize the circuit. All electrical equipment should be properly grounded. Ground fault circuit interrupters are devices that protect against electric shock by quickly de-energizing a circuit when a ground fault is detected. GFCIs should be used in areas where there is a risk of electric shock, such as wet locations. Electrical safety audits should be conducted regularly to ensure that electrical safety practices are being followed. The audit should be conducted by qualified personnel and should identify any areas where improvements are needed. The results of the audit should be used to develop corrective action plans. Maintaining a safe electrical work environment requires a commitment from all levels of the organization. Management should provide the resources and support necessary to implement and maintain effective electrical safety programs. Workers should be actively involved in identifying and addressing electrical hazards. By working together, management and workers can create a safe electrical work environment. Remember, electrical safety is everyone's responsibility.